Okay, this is Unit 8. This is review number 2. There are 6 problems on this worksheet. I'm going to go through the first 2 in this video. So the first one is a cosine graph. There's a linear equation, and then there's the x is equal to 2, which is really going to end up being one of our bounds. So the first thing I'm going to do is go through and graph this. Okay, now I need to notice that the amplitude here is 4 for my cosine, and the whole graph is moved down 3. So when I do this, I'm going to go down 3. I typically put in a dotted line. That's then my new center line for that cosine graph. Amplitude means it's going to go up 4. So it's up 1, 2, 3, 4, puts me up at positive 1, and down 1, 2, 3, 4, puts me down at negative 7. So when I go through and draw this, I'm going to remember cosine starts up at the top, comes down, crosses at pi over 2, bottoms out at pi, comes back up, crosses at 3 pi over 2, and finishes up at 2 pi, up at the top again. So that's my cosine sketch for my graph there. All right, y equals negative x plus 6, so I would have to go up 6. That's 1, 2, 3, 4, 5, 6. All right, so this is, I'm going to do this in another color, up here at 6, and then slope is down 1, right 1. So when I do this, my line is going to come down, it's going to cross through. And then the last thing I have here is that x is equal to 2. And sometimes people get confused as to, okay, where exactly is that? Well, if we have our, this blue point really probably, if I did this correctly, probably should have been over here more. Okay, so I have my x is equal to 1, and then I have my x is equal to 2. The question is, where is that x equals to 2? What I'm going to use is, everyone knows that this is the pi down there. Because we went from 0 to 2 pi. If this is pi, we all know that pi is 3.14. So 2 has to be a little bit less than that. So if this was, say, 1, this is now where my 2 is going to be. That's where I'm going to draw this x equals 2 line coming on through. And what I'm looking for is, where are all 3 of these graphs intersecting to create a bounded region? And that's going to be this area right in here. All right, so that's what I'm going to go through and shade in. So this is my shaded in region. All right, so this is the region that I'm going to be rotating. That's that area that we have. We're going to take that and we're going to rotate that. I'm going to rotate this about the y-axis. So when I'm looking for this, my rotation here, my y-axis is going to be over here. So I'm going to take that and rotate around the y-axis. So that means my rotation here is going to be a right-left. And then when I look at this, I have to decide, what is my area? Can my area be a top-bottom, or can my area be a right-left, or can it be both? And when I look at this, since the right side changes from blue to red, I really don't want to use the right-left method. I'm going to do this as a top-bottom. So since these two do not match up, I'm going to be using the second equation that we've learned. That's the method of shells. So this is going to be the integral of 2 pi x, top minus bottom, dx. And the reason why it is a 2 pi x instead of 2 pi y is because you follow the area, which is the top bottom. So now it's a matter of plugging in the bounds and plugging in the top minus bottom. So if I first just rewrite this, I have an integral 2 pi x, top minus bottom. When I look at this, the top is the blue line. That's never going to change for my shaded regions. So that's negative x plus 6. Minus the red, which is my cosine. So that's going to be minus 4 cosine of x minus 3. And you have to be careful you put that into parentheses. And we want to do that because we need to distribute this minus sign here. I know a lot of us will put this first one in parentheses, so I'll do that right there as well. That's fine. Just got to make sure you're careful when you're plugging this in. All right, and then if you end that parenthesis, and this is, again, a dx. So now I have to determine what is my, or what are my bounds going to be here. Again, if I'm doing this as a top bottom, that means I need to enclose this region on the left, which is this green line, the 2, and on the right, which would be the intersection of that. All right, so I'll go on your graphic calculator, find the intersection of those 2 points, which is, or I'm sorry, those 2 lines, or curves, I should say, which is the negative x plus 6 and the 4 cosine of x minus 3. So again, on the graphic calculator, find the intersection point there, and you want the x value. And that comes out to be 5.688. Now it's a matter of integrating that. I would pull my 2 pi out, and then again, I would use the Math 9 feature on the calculator, and your answer here is 527.59, and that's units cubed because we were finding the volume. Remember, we're rotating the solid around the y-axis there. Okay, number 2. Very similar, we have a couple of graphs here. We're going to go through and graph this. We have the square root of x minus 3. So I'm going to move that down 3. And it's a square root graph. And again, I'm just doing a sketch here, so I'm just going to draw that up. All right, we have y equals 1/2 x minus 3. So again, that's crossing the same spot, the minus 3. The slope there is going to be up 1, right 2. So if I go up 1 now, go to the right 2, I have my straight line, my linear equation coming through. That's the y equals 1/2 x plus 3. So from there, you can now see that this is my shaded region that I'm going to be rotating. So where am I rotating it? I'm rotating around y equals 1. Okay, so y equals 1, remember, that's going to be, this is your y-axis, there's y equals 1. That's going to be this region right up here. So again, I'm going to do that as my dotted line. This is my rotation. So just like number 1, I write this out. My rotation here is going to be a top-bottom. The area, I can do it either as a top-bottom or as a right-left. So I have a choice as to how I want to do this. All right, since the equations are already set up for me as y equals, that means the x's are alone. Or I'm sorry, the y's are alone, that means that we have it in terms of x. I'm going to match it up and do the top-bottom. So I'm going to do this as a top-bottom. So I'm going to use a washer. And then you could also use a shell here. That would work. All right, so when I do this as a washer, that means we're going to have the integral here of, when we first start out, it's going to be your pi, and that's going to be the r squared minus the little r squared. That was the original formula that we used. And we quickly adapted that and said, okay, well, what we really are going to do is pull that pi out in front. And we have, this is the format we would always start with. See, this 2 items squared, which is correct, and this is going to be dx because it was top-bottom, again, based off the area. So there's 3 things we need to decide. One are the bounds. One is, how is this y equals 1 going to affect it? Because we really haven't talked about that yet. And then last is, where are the equations going to go? So first, the bounds. The bounds, since we're doing this in terms of x, we need to find the x values of these 2 intersection points. All right, so this is going to be at 0, and then at 3. So x is 0, x is 3 is where those 2 will intersect. Okay, so again, you can find that on the calculator, or technically you can set those 2 equal to each other. All right, next, this y equals 1. So there's 2 sentences I've always talked about is if it is above or to the right, then it goes in the front. If it's below or to the left, then it goes in the back. So here, this line that we are rotating around is above the shaded region. So since it is above the shaded region, that's the y equals 1. That's going to go in the front. So it's going to be 1 minus, 1 minus. And now this last part, figuring out where those 2 equations are going to go, can be a little tricky, especially since we're doing this not necessarily as a top-bottom now. We're looking at it as furthest minus closest. So in this region, the blue line is the furthest from the pink line. The red is the closest. So the blue line goes in the first one. So that's going to be my 1/2 x minus 3. Again, make sure when you're doing this, you have that in parentheses because you need to distribute that negative. And over here, same idea. We have the square root of x minus 3 in parentheses. If I was to do this problem on the calculator, instead of integrating it by hand, which means you would have to simplify and then actually FOIL both of those parentheses and then do the integral, even without doing that, I still think I would take this and simplify this a little bit. So what I mean by that is I'll take this minus sign, distribute it through. So this is going to be now, in this first set of parentheses, we're going to have a 1 minus a negative 3. That's 1 plus 3 is a 4 minus 0.5x. So I think it's easier to plug it into the calculator in that format. Minus, now my second set of parentheses, again, 1 minus a negative 3 is going to give me a 1 plus 3, so that's going to be a 4 again. And this is going to be minus the square root of x. And that is all squared, dx. Again, I would use the math9 function feature on the calculator. Type it in, and you get 25.133. That's units cubed again.